So you guys have all been asking. We are doing our last, well, not our last, we're doing our next trig function today, which is tangent. So we've done sine and cosine, and sine and cosine are pretty much the basis for all of trig functions. So now we're going to bring in tangent. So let's review what tangent actually is based on the right triangle. Yeah, so we got here, tangent is your opposite over your adjacent side. And I got my little picture of my triangle over there to the right. Opposite over adjacent, yes, your TOA. So example 1, for each of these right triangles, we're going to state what the sine value is, the cosine value, and then the tangent value. But looking at that first right triangle, we have a side that's missing. How do we find that missing side? Pythagorean theorem is one way. So you could do your a squared plus b squared equals c squared. And sine squared plus cosine squared equals 1. No, because we don't know the sine value or the cosine value. False. This is one of our triples. Does anybody remember the triple? Something 4, 5. 3, 4, 5, Pythagorean triple. That wasn't painful at all. All right, then you just got to do Pythagorean theorem. So the sine of our angle would be opposite over hypotenuse, so 3 over 5. What would our cosine be? So 4 over 5. And tangent?
3 over 4.
3 over 4. There we go. So let's try it again. We got to find our missing side for our triangle over there in B. This one's not a triple though, so we're going to have to do Pythagorean theorem.
45, 45.
So a squared plus b squared equals c squared. What is 1 squared? 1. 2 squared? 4. So subtract our 1 over.
Radical 3.
And then we take the square root, and x equals radical 3. So our missing side there is radical 3. So now we can find sine is what?
So radical 3 over
2.
Yeah.
Yes. What would our cosine be? 1 over 2. And our tangent?
Radical 3 over 1.
Which is just
Radical 3.
radical 3. So that's the way you're used to doing it. Sine, cosine, and tangent, our little SOHCAHTOA there. So now, as we've been doing with our sine and our cosine, we turned it into terms of the unit circle. We're going to turn our tangent into terms of the unit circle also. So you can use Pythagorean theorem to find your missing sides, or we can look to our unit circle. So if xy represents a point on the circle, let's refresh our memories. X represents which one? Cosine. Y represents sine. But if we look over here at our unit circle, tangent, as we said, is the opposite side over the hypotenuse. So what's the side opposite of our angle there? Y. And the adjacent? Over x. So in terms of our unit circle, tangent is going to be y over x. Now if we plug in our sine and our cosine values, sine is our y, cosine is our x. So tangent is the same as sine over cosine. Sure. So we can use it as y over x if you know the coordinate points off the unit circle, or if you know your sine cosine values, you would just put sine over cosine, and that's how you would get your tangent. So there's our definition, tangent theta equals sine over cosine, as we just said. So using the unit circle and the definition of tangent in terms of sine and cosine, find the values for each of the following. Do not leave any complex fractions. Complex fractions means you have a fraction within a fraction. So for tan of 60, that means we're going to take the sine of 60 and put it over the cosine of 60. So what is the value of the sine of 60? Use your unit circle. Find the y-coordinate for 60. Radical 3 over 2. What's cosine 60? One half. But we can't keep that as that. We can't have two fractions within another fraction. So how do we clean up our fractions? Keep, change, flip. So radical 3 over 2 times 2 over 1. I change it to division. Flip my second fraction. What happens with our 2's? They cancel. So we're left with radical 3 over 1, which is just what? The tangent of 60 is radical 3. So let's try it for 45. So tangent of 45 is going to be the sine of 45 over the cosine of 45. So what is sine and cosine of 45?
Radical 2 over 2.
Radical 2 over 2 over.
Radical 2 over 2.
So anything over itself equals what?
1.
1. So tangent of 45 is 1. So 150 again is going to be sine of 150 over the cosine of 150. So what is our sine of 150? 1 half. Cosine of 150? Negative radical 3 over 2. So now we'll do our keep, change, flip. So 1 half, change to multiply. Flip my bottom fraction so it becomes negative 2 over radical 3. 2's cancel out. So I get negative 1 over radical 3. Can I leave that though? No, we can't have a radical in the bottom. So what do we have to do? You can't just flip it. Multiply top and bottom times that radical 3. So we have negative radical 3 for the top, and then radical 3 times radical 3 is 3. So tangent of 150 is negative radical 3 over 3. That wasn't too bad. So for 180, so we're going to have the sine of 180 over the cosine of 180. So what is the sine of 180? No. 0. Cosine is the negative 1. So 0 over anything is simply 0. So because the tangent function involves division, you can sometimes end up with an answer that's undefined. So let's take a look, for example, at 90 degrees, or pi over 2 radians, whichever one you want to call it. What is our sine value of 90? 1. What is our cosine value of 90? 0. So when I go to do tangent of sine over cosine, I would have 1 over 0. Can we divide by 0? No. So this ends up being undefined because you cannot divide by 0.
Oh, no.
So the next one wants to know at which of the following angles is tangent undefined. So again, tangent is your sine over cosine. So really, anytime that your cosine is a 0, that is when your tangent is going to be undefined. So what is the cosine of 1? Or I'm sorry, of 0? 1. I just said it was 1. What's our cosine of 270? 0. There we go. So this one's going to end up being an undefined tangent value because your cosine is a 0. So on a final note, it's interesting that if we know sine and cosine of an angle and the quadrant of the angle, we can find the other two missing trig values. So 6, they want us to figure out cosine and tangent if sine is 5 over 13 and the terminal ray of the angle lies in the second quadrant. So let's draw an x and y axis since they talk about the second quadrant. So my angle is going to go up here into the second quadrant. Since we're talking about the sine, cosine, and tangent, I'm going to connect it down to the x-axis to make a triangle there. And we're going to be dealing with our little reference angle right in there by your origin. We're always going to deal with the angle by the origin. Stop it, Casey. So they tell us sine is 5 over 13. So that is your opposite side and your hypotenuse. So my opposite over here are 5. 13 is my hypotenuse. We got to figure out that missing side of our triangle. It's another triple, 5, 12, 13. But since we are in the second quadrant, that 12 ends up being negative because you're going to the left on your x-axis, so it's a negative 12.
How is that triple? 5, 12, 13?
Okay, so now that we know all three sides of our triangle, we can find our cosine and tangent, which is what they asked us to find. So what would be the cosine of our angle? Don't all shout out at once.
I did. 12. 12.
Adjacent over hypotenuse, so it would be negative 12 over 13. And then our tangent?
Opposite over adjacent, 5 over negative 12.
There we go. And now remember, this connects back to what we had talked about before with the signs of our trig functions. All of them are positive here, only sine is positive here. As you see, our cosine and our tangent were both negative. Third quadrant, only tangent's positive, and then the fourth quadrant, only cosine is positive.
All students torture children.
All schools torture children.
All students. I messed it up. Like I messed it up.
All right. Last one on this page. If cosine A theta equals A, where A is greater than 0, and the terminal ray lies in the fourth quadrant, then which of the following gives the value of tangent A in terms of A? False. So, first thing we have to start with is the Pythagorean identity that we talked about a few days ago. Sine squared plus cosine squared equals 1. Because remember, tangent we now know to be sine over cosine. I have my cosine. We got to figure out what our sine value is going to be. So we're going to plug in the letter A for cosine. So sine squared plus A squared equals 1. We want to get sine by itself, so what are we going to do with our A squared? Subtract it. So sine squared theta equals 1 minus A squared. And then how do I get just sine? Take the square root. But keeping in mind, we are in the fourth quadrant. Is sine positive or negative there? Negative. So we want the negative square root of 1 minus A squared. That is going to be sine. So now, tangent is sine, which is this, over your cosine. So which one matches that?
That wasn't right. I was right. What? How do you know that A is a cosine? Who was right?
Because it told me right here.
Guess who was correct? It wasn't a wild guess. I just know math, and you said it was wrong.
All right, so our last thing for us to do in our trig unit are the reciprocal functions. So you guys know about your sine, your cosine, and tangent, your SOHCAHTOA. So now we have our reciprocals. All three of those trig functions do have a reciprocal value that goes along with it. So our reciprocal functions are secant, which is the reciprocal of cosine. And then we've got cosecant, which is the reciprocal of sine. For some reason, my cotangent fell off here. So cotangent, you're going to have to write that in there. The letters they use for it is COT of theta is 1 over tangent. That's the reciprocal of tangent.
What does that say?
Cotangent. Or for your cotangent, instead of doing the 1 over tangent, since we now know that tangent is sine over cosine, all we would have to do is flip that. And cotangent would be cosine over sine. 1 over tangent theta. So I find the trickiest part with your reciprocals is remembering which one goes with which. So one trick that I always use is every reciprocal pair has to have one of them that is a cofunction. So secant goes with cosine, because secant's not a co, but cosine is. That's how I remember those go together. Cosecant goes with just sine, so you got one of them that's just got that co somewhere. And then cotangent and tangent, that one's the easiest one. I remember back when I was learning this, I always get so mad. I'm like, if it's cotangent and tangent, why doesn't cosine and sine be the reciprocals? It just didn't make sense to me, but it's the way it is. All right, so considering our work with sine and cosine, evaluate each of the following and express your answers in exact and simplest form. So secant. Secant is the reciprocal of which one? Cosine.
Oh.
One of them's got to be a co. So secant doesn't have a co, so the other one has to be cosine. So what is the cosine of 60? 1/2. So our secant is the reciprocal of that, so that means all we have to do is flip it.
2.
So the secant of 60 would be 2. No, because what I did is I figured out cosine, and then I just take that value and you flip it. That's your reciprocal. The other way you could do it is it's 1 over 1/2, in which case you would do your keep, change, flip, so it's 1 times 2, 2. The short way is to just flip your fraction. Okay? All right, so cotangent. Cotangent, remember, is going to be cosine over sine. I won't have to end up flipping this one because I've already flipped it by putting cosine over sine. So what is our cosine value of 150? No, -1/2. And then sine of 150? Wait, no, I have that. Nope, Tim, you were right. Brain fart. Nice job, Tim. So it's negative radical 3 over 2 over 1/2. So then I got a fraction divided by a fraction. What do I have to do? Keep, change, flip. So what happens with my 2's? They cancel.
Why did you put cosine 150 on the top?
Because it's cotangent, so it's tangent flipped. So it should just be negative radical 3. So then C, we have cosecant of 3 pi over 4. Let's first turn that into degrees. So 3 pi over 4 is how many degrees? 135.
Oh.
That's cosecant.
Oh.
Yeah.
Oh.
But cosecant.
Cosecant is the reciprocal of sine. So what is the value of sine of 135? Because it's 3 times 180 divided by 4. Gives us 135. Day 1. Go back and look at day 1. So sine of 135. 2 over radical 2. So yes, when we flip it, sine was radical 2 over 2. So we flip it and it becomes 2 over radical 2. But can we leave it like that? No. What do I have to do? Yes.
What the heck is happening to you?
What?
How'd you get 2 radical?
So we get 2 radical 2 over 2. So that reduces to be just radical 2. So cosecant of 135 is simply radical 2.
Right.
All right, number 2. Which of the following is closest to the value of secant of 152? So in your calculator, you're not going to want to find the sine of cosine of 152 and then flip it. What we want to actually do in the calculator is you're going to do 1 divided by cosine of 52. That's how you would get your reciprocal function. But there's one thing you have to be careful of. What form is our angle in? Degrees. Make sure your calculator's in degree mode, otherwise you're not going to get the right answer. So go to mode and make sure degree is highlighted. Yeah. So when you have it in degree mode, you get the correct answer of choice 2. So because each of the reciprocal functions has a variable denominator, there will be angles at which these denominators are 0, so sometimes they end up being undefined. So which of the following values of x is not in the domain of cosecant x? So you got to think to yourselves, okay, cosecant is the reciprocal of which one?
That's the first one in English.
Sine. So cosecant is the same as 1 over sine x. So in order for that to be undefined, our sine would end up having to equal 0. That's how we get an undefined, is if your denominator is 0. So which one of these has a sine value of 0? It would be choice 1, 180. Last page of notes here. So because each of these functions is dependent on sine or cosine, it is possible to determine their values, whether it's positive or negative, based on the quadrant in the input angle. So these follow the same pattern I was just talking about. All schools torture children. So all of them are positive in the first quadrant. Only sine is positive in the second quadrant, tangent in the third, cosine in the fourth. So the reciprocal functions go along with the originals. So since sine is positive here, that means cosecant is also positive there. Tangent is positive down here, so cotangent is also positive there. And then secant is positive where cosine is positive. Those are just a variable. That's another Greek letter. So cotangent in quadrant 2, is that going to be positive or negative? Negative, because the only thing positive in quadrant 2 is sine and cosecant. So letter B, secant in quadrant 4, is it going to be positive or negative? Positive. Because secant is the reciprocal of cosine. Cosine's positive in quadrant 4. Secant also.
What letter is that before the SEC?
Where?
C. CC?
Here?
Yeah.
C, that stood for
No,
cosine.
that one after that.
And then that's an arrow.
Oh, I didn't know that. I thought that was
So then cosecant for quadrant 3. Positive or negative? Negative, because the only ones positive in quadrant 3 are tangent and cotangent, so everything else is negative. Sine. All right, so cotangent is less than 0, so that means it's negative. Secant is greater than 0, so that means it's positive. Then theta could be which of the following angles? Well, let's figure out first what quadrant are we in. Cotangent is negative, and secant is positive. So secant goes along with which one again? Cosine. Secant goes with cosine. Cosine is positive over here in either quadrant 1 or quadrant 4. So that means secant is also positive in 1 and 4. Which one has cotangent being negative? Quadrant 4. So that means we're down here. Which of our 4 choices is in quadrant 4? Yep, choice 2, 310.
Oh my God, we're almost done now.
So just like we were doing with our tangent, you can find all 3 of your trig ratios with any triangle. You can also find all 6 of them now. You would just find your sine, your cosine, and your tangent, and then flip them, and that gives you your reciprocal ones. So first thing we got to do in our triangle over here is we have to find our hypotenuse in terms of A and B. So we would do that using our Pythagorean theorem. A squared plus B squared equals C squared. What would we do to get C squared to be just C?
Square root.
Square root. So the square root of A squared plus B squared equals C. So that's what we label the hypotenuse of our triangle with, the square root of A squared plus B squared. So if we look at our ratios, we're finding the sine of angle A, cosine of A, tangent of A. So that means we're down here at angle A. So sine, opposite over hypotenuse, what would be our letters? There we go. And since they're variables, we can leave it like that because it could very well be that A squared plus B squared is a perfect square and then you don't have the radical in the denominator anymore. So with variables, we can leave that. What would cosine be?
B over radical A squared plus B squared.
Nice job, Johnson.
Where are you getting this for top from?
And tangent?
A over B.
A over B. So then our reciprocals, all we got to do is flip them. So cosecant is sine flipped, so that's radical A squared plus B squared over A. So what's secant? Opposite of cosine. So square root of A squared plus B squared all over B.
B over A.
And then cotangent is B over A.
So you're going to be a B word in the test.
So if alpha, that's what that little squiggle is an angle whose terminal ray is in the 4th quadrant, and cosine of alpha is 1 over 3, then determine the exact value of cosecant alpha. Show how you arrived at your answer. So let's draw a little picture. We are down here in quadrant 4. Again, here's my angle. It's always that one up by the origin.
Wait, is spring break next week?
Cosine is 1/3, so that means the adjacent over the hypotenuse. We got to figure out what our missing side is. but not 2 squared equals
Oh,
3
it's
squared.
just 3?
That's a 3.
Oh, it's radical 3.
It is not radical 3.
Radical 5.
Yeah.
No.
Oh,
No.
I'm going to figure this out. 150?
No.
Radical 8. 2 radical 8. 2 radical 3. You guys are stupid. Radical 8. You're dumb.
2 radical 2.
Well, also radical 3.
But this is going to represent the side of the triangle that is going down. So is it 2 radical 2 or negative 2 radical 2? Negative. So cosecant is the reciprocal of which one? So sine of alpha would be negative radical 2 over 2 over 3. So our cosecant would be 3 over negative 2 radical 2. And that's our answer, right?
Is that an A?
It's alpha. Kind of. Can I leave my answer that way?
Did Jesus Christ?
No.
Wait, that's sin what?
Sine of alpha.
Alpha.
It's another Greek letter. So we would get 3 radical 2 in our numerator. And then what's radical 2 times radical 2? Radical 2 times radical 2. 2, and then times this 2. Negative 4, and I already got my negative out in front there. So there's our cosecant.